Welcome back. Today's section is section 9.1.3. We will be talking about significance levels, critical values, test statistic. So before I jump into the topic, I highly recommend if these terms are new to you, go back and take a look at the previous sections. All right. So now let's go ahead and see what a significance level is and what our critical regions are. Remember in statistics, you take your sample, right? If you're trying to do your hypothesis testing, you take your sample. The first thing you do is you write your H naught and HA. So this is where the whole concept of hypothesis testing lies. You have your H naught, you have your HA. So either you tell me that your H naught is true or your H naught is false. Because these are mutually exclusive, if your H naught is true, automatically your HA becomes false. If your H naught is false, automatically your HA becomes true, right? So that's the whole concept of it. But in statistical terms, you don't say true or false. You say you reject your H naught, so your HA is true, or you fail to reject it. So when you're failing to reject, that means you're keeping it. So your HA is gone and you only have H naught. Okay? Either you reject it or you fail to reject it. Only two things will happen in your hypothesis testing. And you always talk in terms of H naught. So either you reject your H naught or you fail to reject your H naught. This is a good segue into what a significance level is. Remember your confidence interval. So if you're 95% confident, there's 5% chance you will make an error. If you're 99% confident, there's 1% chance you will make an error. And that 5% or 1% is called type 1 error. And that is your significance level. What exactly does that mean? Your significance level is the probability that you will be rejecting your H naught when your H naught is actually true. Okay, so let me repeat this. Your significance level is you are rejecting your H naught when your H naught is actually true. So let's go ahead and take a look. Significance level in probability is rejecting your null hypothesis, which is your H naught, when in fact it is true. So the most used significance values are 99% confidence, 95%, 90%, but these values will be given to you in the problem. All right. Now, once we know what significance level are, let's go one step further down and look at left-tailed, right-tailed, and two-tailed. Remember what we talked about? You always look at your HA. If your HA is greater than, it's your right tail test. If your HA is less than, it's your left tail test. If your HA is not equal to, that means it could be greater than or it could be less than. So it's a two-tailed test. All right. So always your HA will tell you if it's left, right, or two-tailed. And this region is called your rejection region. This is your rejection region. So this is right here. All this shaded part is your rejection region if it's a two-tailed. If it's a left-tailed, it's towards your left-hand side, right? As simple as that. If it's right-tailed, it's towards the right-hand side. That's your rejection region. Now, what do I mean rejection region? When you take your test statistic and your test statistic falls in the rejection region, that means you will be rejecting your null hypothesis. So the word itself tells you it is your rejection region. Always keep in mind, you only talk in terms of H naught. Either you reject it or you fail to reject it. So if your test statistic falls in the rejection region, you reject your null hypothesis. Now let's go ahead and take a look at it in simple terms. In simple words, this is the way I put it down. I highly recommend you write this down on your note card. In simple words, significance level, which is alpha, is there is alpha percent chance you conclude HA, but in fact H naught. So technically what I'm saying, significance level is the probability of rejecting H naught. So when I'm rejecting, this is my H naught, this is HA. So H naught is true, but I'm rejecting it. So what am I left with? HA. So significance level is you conclude your HA is true, but in fact your H naught should be true. Okay, now let's go ahead and take a look at the problem. Always keep in mind your H naught is true, but significance level is instead of taking H naught, you say your HA is true. All right. An allergist is interested in studying the proportion of teenagers that are allergic to pollen. Actually, my sister does a lot of research on allergies. The allergist states the proportion of teenagers that are allergic to pollen is less than 0.45. So this is what the allergist is stating. So the allergist is saying, the teenagers that are allergic to pollen is less than 45%, 0.45. First step, before I jump into the problem, I need to write down what my HA is, what my H naught is. My H naught is always going to be standard equal to, right? That's how H naught is. HA is the one that changes. So what is it talking about? Proportion. So P, I'm starting with my HA. P is less than 0.45, right? HA, exactly the same except the sign. So P equal to 0.45. As simple as that. All right. If we would like to test this allergist claim with a hypothesis test using significance level, so this is my significance level, 0.01. Which of the following choices are true? Remember what the significance level says. There is alpha% chance that you conclude HA instead of H naught. Okay, so keeping that in mind, let's go ahead and take a look at this one. There is alpha% chance, that means there's 1% chance here because my alpha is 0.1. There is 1% chance that I will conclude HA. What is my HA? That the proportion is less than 0.45. In fact, when my H naught is true, what is my H naught? As you can see, my H naught is 0.45. Now let's go ahead and look for these key terms in the options. So my alpha, there is 1% chance that we conclude, yes, HA. Remember, this is my HA. The proportion is less than 0.5, but in fact, this is my H naught is 0.45. So that's the first option. There is 1% chance that the proportion is less than 0.5. No, that's only half of what I know, right? So that's not true. There is 1% chance of rejecting the null hypothesis. That's only half of what I know. There is 1% chance we conclude. Remember, alpha is you always conclude about HA, not about H naught. So this is also wrong. So the easiest way is to start with your alpha and you conclude HA. In this case, what's my HA? Zero. Proportion is less than 0.45. So you're concluding proportion is less than 0.45 when actually it is equal to 0.45, which is your null hypothesis. So in this case, my option A is my right answer. Okay, let me go ahead and highlight that. I'm going to go ahead and use what color? I'm going to use yellow. So this is going to be my right option. Okay, you always will be using there is alpha% chance. You conclude HA when in fact H naught is true. Let's go ahead and take a look at the next one. Okay, an accountant is struggling how much American families donate each year to charity. The accountant states the average yearly amount donated to charity by American families is different than $5,500. Again, I start with my H naught and HA. I always come to HA later. I talk about the claim in this case. So who is he? An accountant. So what is the accountant claiming? It's different. When he uses the word different, that means he's not talking about less than, he's not talking about greater than. He's saying different is not equal to. Okay, so always keep in mind different is not equal to. So let's go ahead and take a look here. I'm going to change my pen color to green. And he says the average is mu. So keep in mind proportion is P, average is mu. You should know those symbols by now. So mu, he says it's different. That means it's not equal to 5.5 thousand. 5.5 thousand. And again, my H naught is as simple as that. Everything stays the same, but instead the sign automatically changes to equal to. Okay? Remember what significance level is? There's alpha percent chance. You conclude HA when H naught is true. So there's 5% chance we conclude HA. So this is not my HA. The terminology has to be exactly like the way I'm saying it. There is 5% chance of rejecting. That's not the terminology that we use, right? There is 5% chance we conclude. We conclude what? HA. What is my HA? Mu not equal to 5.5. So mu not equal to 5.5, but in fact H naught. What is my H naught? Mu equal to 5.5. So I'm guessing this is my right answer because the terminology is also the same way. There is alpha percent chance you conclude HA when in fact H naught is true. All right. So the next one is understand and interpret critical values. Remember when critical values come into play? The previous section was about significance level. Significance level is when I use the probability, right? Critical values is when I use the rejection region. Certain terminology that you have to know is what critical values are. What are they? They're computed from significance level and test type. Significance level is the probability of rejecting null hypothesis when actually a null hypothesis is true. Rejection region is the set of values that when your test statistic falls in the rejection region, automatically it gets rejected. Remember, in your hypothesis testing, you always focus on either rejecting your null hypothesis or failing to reject. So when do you reject? You reject when your test statistic falls in the rejection region. But the terminology is very important, so let's go ahead and take a look. Falls in rejection region, only two things can happen, yes or no. So when it falls in the rejection region, because it is falling in the rejection region, I have a strong evidence to reject my null hypothesis. Remember, you only talk about null hypothesis. Alternative is very important, but it only comes into play. It's understood, but you always talk in terms of null. So two things can happen. Either the test statistic can fall in the rejection and cannot. If it falls in the rejection, you say you have a strong evidence to reject your null hypothesis. If it doesn't fall, there is not sufficient evidence to reject your null hypothesis. Remember, you're either rejecting or you're not rejecting. When do you reject? When it falls in the rejection region. You have a strong evidence. When it doesn't fall, you don't have strong evidence to reject your null hypothesis. This terminology is very important. So let's go ahead and take a look. When it's a two-tailed test, so here I have it. When it's a two-tailed test, I'll use green. So these are my critical values. The ones in red are my critical values. And again, you will get all these information from your class calc, and you can also use technology to get these critical values depending on what we are doing. Okay, again, the critical values are nothing but your z-scores. Remember, z-score is nothing but that many standard deviations you are away from the mean. So they all tie into one another. So knowing what the terms are is very important. So if it's a two-tailed test, I'll have two critical values. If it's a left tail test, I have only one critical value. This is my critical value. Do you see that? The one in red. That's my z-score again. If it's a right tail test, I will only have one critical value. So anything beyond the critical value becomes the rejection region. All right. Now let's go ahead and take a look. Jonathan, a manager at advertising firm, believes proportion is again P, of business relying on print media for advertisement is changing. Of course, it's changing because we have social media, we have everything else. So, business totally on print media definitely is changing. He would like to test the claim that proportion of business relying on print media for advertising is different. Remember what we talked about? Different doesn't mean less than. Different doesn't mean greater than. Different means not equal to. Different than 18%. Using computed test statistic. Now I want you to pause for a minute and see what happens. Test statistic. So what do you think this person did? He took a sample. He wrote his H naught, HA, he did his math, and he got the test statistic from the sample. So we are not seeing what he's doing in the back end, but that's exactly what's happening in the back end. So he did the math and he got his test statistic as -1. And the critical values are -1.28, +1.28. How do I know there are two? Because it says it's different. When it's different, it's not equal to. When it's not equal to, I have one on the left-hand side and one on the right-hand side. All right. Always, 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 I would like to go ahead and start with my H naught and HA and also the claim. What is he claiming? So Jonathan claims the proportion is not equal to 18%. Okay, proportion is not equal to. What is my H naught? H naught is blindly proportion equal to 18%. Always write down your HA. Proportion not equal to 18%. This is what he claimed. And my claim is my HA. Do you see that? For H naught, you don't have to think. It's always equal to, equal to, equal to. Now, I have to talk about my tailed test. What tailed is it? Left-tailed, right-tailed, or two-tailed? What do I do? To find out what tailed it is, I simply look at my HA. My HA is not equal to, so I know it is a two-tailed. You will not be asked all of this in the test, but or even in your homeworks, but it's very important you know and you understand the basics. So the solving of the problem becomes much more simpler. Critical values, they already gave me the critical values, right? These are my critical values, -1.28 and +1.28. What is my test statistic? It is -1. Do you see that? Okay. Once I have that, remember only two things can happen. My test statistic can fall in the rejection region or cannot fall in the rejection region. If it falls, I have a strong evidence. If it does not, I don't have sufficient evidence to reject my null hypothesis. So let's go ahead. What I'm going to do is I'm going to go ahead and open up your homework problem so I can show you how to move things around and then we'll work it from there. Okay, so here I have it. So based on the problem, you always start with its left, right, or two-tail. So I know it's my, okay, let's do this again. So to start, cut, cut, okay. So here is the problem that I have. I'm going to go ahead and start with what tailed test it is. I'm going to move it. No, not left tailed, not right tailed. but I know it is a two-tailed, right? Not equal to. The next thing is my critical values. So I'm going to move things around here. What are my critical values? My critical value was negative 1.28, positive 1.28. So make sure you have those values in your class calc. And sometimes if you cannot move it, uh, press and hold control and plus button so it can zoom in. I'm going to go ahead and move the right hand side. It's 1.28 moving to 28. There you go. And on the left hand side, it is negative 1.28. There you go, I have it. My test statistic is negative 1. So I'm going to go ahead and move it. No. Negative, yeah, negative 1. All right, come on. There you go, negative 1. Now, take a look if this is inside the shaded region, which is your rejection, or outside. When I'm looking at it, it's outside the rejection region. It's not inside. So I only reject if it's inside. If it's outside, what do I say? Let's go ahead. So you saw that? The test statistic is not inside the rejection region. It did not fall inside the rejection region. So what do I say? Did the test statistic fall? No, it did not. So there is not sufficient evidence to reject my null hypothesis. That has to be your exact terminology. So I know because the test statistic did not fall in the rejection region, the terminology I use is there is not sufficient evidence. Always have this table with you. Always have this table with you so you know what the terminology is going to be. So I'm going to go ahead and look for no because it did not fall in the rejection region. So definitely this is not my answer. Definitely this is not my answer. My only options are, let me change the color here. My only options are B and D, right? B and D. So let's go ahead and read B and D. No, yes, it did not fall in the rejection region. There is not sufficient evidence for the manager to reject the null hypothesis because the test statistic does not fall in the rejection region. Yes, that's the right answer. Let's go ahead and read the next one. There is not sufficient evidence for the manager to reject the null hypothesis because the critical value, no, we're not talking about critical value. We only talk about test statistic. So this is not my option. My only option here is option B. And that automatically becomes a straight line. There you go. My option is option B. Now let's go ahead and do one more problem. Again, be very careful. Please pause, read the problem, and then start. A pharmacist believes a proportion, again P, of prescriptions that are antibiotics is decreasing. The pharmacist would like to test the claim that proportion of prescriptions that are antibiotics is under 52%. Using the computed test statistic of negative 1.8. I'm going to go ahead and highlight the things that I think will be important to me. Antibiotics under 52%. My test statistic is negative 1.8. My critical values negative 1.65. I'm going to give you a hint here. If they give you only one critical value, that means either it's left-tailed or right-tailed. But look at the critical value. The critical value is negative, so automatically it is left-tailed. So the questions are always giving you the answers. You just have to be patient and listen to them. All right. So the critical value is negative 1.65. They're asking you, is there enough evidence for the pharmacist to reject? Keep in mind, when do I reject? I only reject when the test statistic falls in the in the rejection region. So let's go ahead and take a look if it falls. But before you do that, write your H naught, HA, critical values, test statistic, left, right, or two-tailed. So because you have a good idea of what's happening, then you simply go ahead and move your sliders. All right. So the claim, what was the claim? He says the proportion is under, so it's less than 52%. You don't have to write the claim, but I like to write the claim because that's what I'm testing, right? My alternative proportion is less than 52%. My null hypothesis, I don't have to think, it's always equal to 52%. Tailed test, because it's less than, because my alternative is less than, I know it is left tailed test. Critical values, my critical value is negative 1.65. My test statistic is negative 1.89. Remember, two things can happen. Either it can fall in the rejection or not fall in the rejection. Now let's go ahead, take a look at the slider of this problem. So here I know it's a left tail test, so I always start with moving the dots. Left tailed, there you go. My critical value was negative, I forgot. It was negative 1.65. Okay. My critical value was negative 1.65. Come on, help me out here. So this is my critical value, negative 1 point, going further down, 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 down. There you go, negative 1.65. And my test statistic was negative 1.89. So I'm going to move it all the way to the left. Boom, 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 boom. 1.89. Oh, there you go, 1.89. All right, one more. There you go, 1.89. Now take a look. Look what the test statistic is. It is in the rejection region. It's falling in the shaded region. When it falls in the shaded region, I have strong evidence to reject my null hypothesis. Okay, so take a look at this again. Pause if you have to. You see where the red line is? The red line is inside the shaded region, unlike the previous problem. So if you want to rewind and take a look at the previous problem, in the previous problem, the test statistic was outside the shaded region, like this, outside. But in this case, it's inside. Oh, now I missed it. Now, in this case, it's inside the test statistic, inside the critical region. Okay, so because it's inside, I know I'm rejecting my null hypothesis. So let's go ahead and take a look at the options. So did the test statistic fall inside the rejection region? Yes. So I don't care about the no's, right? Da, 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 the B and D are gone. You see how you can choose from your options? Yes, it did fall. So when it falls, I have strong evidence to what? To reject my null hypothesis. So there is sufficient evidence for the pharmacist to reject the null hypothesis because the test statistic falls in the rejection region. This looks like a right answer to me, but go ahead and read the next one as well. Yes, there is sufficient evidence for the pharmacist to reject the null hypothesis because the critical values, no, we're not talking about critical values. We only talk about the test statistic. Critical values will always be there. I can't change them, right? Only the test statistic. Write this down if you have to. So my answer is option A. There you go. All right. All right, now let's take a look at the next topic. Understand and interpret the test statistic and p-values. God, this is so hard to say the word test statistic. Okay. The p-value is the probability of getting the test statistic as different or more different from the parameters specified in the null hypothesis. Now, I will talk about it in detail. So the test statistic is a quantity that represents how much our random sample differs or agrees with the parameter of claim. So what does that mean? Remember, I claim something and you take a sample. Now you conclude based on your sample. Now the probability, how weird is this sample, depends on what your conclusion is. So that's exactly what the p-value is. The p-value is telling me how different is this sample from the norm. So a test statistic is the quantity that represents how much our random sample differs from or agrees with the parameter in the claim. Formally in hypothesis test for the mean, the test statistic is the number. Remember, test statistic is the number of standard deviations away from the parameter claim because it's the z-value. The test statistic is the z-value. We will be doing two different types of tests deeper into the course, but as of now, we will look at test statistic as the number of standard deviations from the parameter of the claim. All right. Now, so what happens? We've seen the rejection region. If it falls in the rejection region, boom, you reject. The next is the p-value. Remember, you compare your p-value to alpha. What is alpha? Alpha is your significance level. What is your significance level? It's the probability that you reject your null hypothesis when it's actually true. So there are two things that can happen. You will take your p-value after doing all the math. We'll go about that in the next section. Once you have your probability, remember what this probability is. This is telling you how different is this sample from the claim. If the sample is way different, then whatever I am claiming, you might be like, miss, you might be claiming wrong, right? So we want the sample pretty close to the claim so we can get the accurate answer. So here you take your p-value and you compare it to alpha. So only two things can happen. Your p-value. So if the p-value is less than or equal to alpha, then you reject your null hypothesis. Again, keep in mind, when the p-value is less than or equal to alpha, you reject your null hypothesis. That means you have strong evidence. Keep in mind, you only reject when you have a strong evidence. So you will say there is enough evidence at alpha significance level to support the alternative. So you're rejecting your null hypothesis. So let's just say, yeah, let's take two different pens. I'm going to take yellow and I'm going to take red. Can you see this? Yeah, yellow and red. So my yellow is null hypothesis and my red is alternative. You only reject your null hypothesis when you have a strong evidence. So in this case, when P is less than or equal to alpha, you reject your null hypothesis. I am rejecting my null hypothesis. What am I left with? Alternative. Okay? All right. Let me do one more really quick. So here I have it. I have my null hypothesis and I have my alternative hypothesis. I only reject my null hypothesis when I have strong evidence. So what am I telling you? There is strong evidence. I rejected my null hypothesis. That means what am I supporting? What am I left with? Alternative hypothesis. Fair enough? So when you fail to reject, when you're failing to reject, that means you're keeping this one. When you keep this one, this automatically drops down. You only have one. Okay? You reject null hypothesis, you're left with HA. You fail to reject, that means this drops down. Fair enough? All right. So when you're the terminology is very important. Again, the terminology is when P is less than or equal to alpha, you reject null hypothesis. That means there is enough evidence at alpha significance to support my alternative. Keep in mind, I'm rejecting this, I'm supporting this. Okay? Okay. The next option is if P is greater than alpha. If P is greater than alpha, then I fail to reject my null hypothesis. That means what drops down? My alternative drops down. So that means there is not enough evidence at alpha level significance to support my alternative. I can support this one because I am failing to reject my null hypothesis. And this verbiage is very important. All right, now let's go ahead and take a look at the problem. Dan, a stockbroker, is studying dividend earning from stocks. He would like to test the claim that the average dividend earnings per share of a stock is more than 1.6 dollars if the Z test statistic was calculated. So I do have my test statistic, which is 2.85. Does the stock does the stockbroker have enough evidence to reject the null hypothesis? Assume alpha is 0.01. Again, sometimes you don't have to write your claim. I'm going to start with my H naught and HA. So what is he saying? He would like to test the claim the average dividend earning per share is a more. So I'm going to go ahead, average is mu. So mu is greater than 1.60. That's my alternative because it's greater than. Remember what my null is? Simple, always equal to, blindly. Do I have my alpha? Yes, my alpha is 0.01. What is my test statistic? Which is 2.85. What is my p-value? Let's go ahead and look at the problem and get our p-value. So here I am. As you know, it's greater than. So it's a right tail. My first step is to move it to the right tail. That's left. There you go. That's right. Next is my alpha. My alpha is 0.01. Where is it? Dun, dun, dun. 0.01. There's my alpha. And my test statistic is 2.85. So let me go ahead and move my test statistic. Moving all the way to the right. And you can see the test statistic value is moving up. 2.85. I'm going to move it further. There you go. $2.85. There I have it. So once you have this, you need to go ahead and take down the p-value. So based on this one, look what my p-value is, 0.0022. That's my test my test statistic is 2.85 and my p-value is 0.002. So there are two ways to look at it. As you can see, the test statistic falls in the critical region. That's one way of looking at it, or rejection region. And I can also compare my p-value to alpha. So let's go ahead and do the second method, comparing the p-value to alpha because they asked us to. And the p-value from here is 0.0022. All right. So my p-value is 0.0022. What do? I compare my p to alpha. So what is my alpha? My alpha is 0.01. And I see that my p-value is less than alpha. When my p-value is less than alpha, what do? I reject my null hypothesis. But if you go back and look, I can even use my rejection region. The test statistic is actually boom inside the rejection region. You can choose whichever method you want. They will finally take you to the same conclusion, p-value or the rejection region. Okay? All right. So I'm comparing my P to alpha using the sliders. I move the tail test first and then the alpha value and then the test statistic. But please make sure your sliders, all three sliders are on the right spot. Your right tail, yes. Your alpha, check. Your test statistic, check. Once that's done, that's when you pick your p-value. Make sure you go ahead and do that one more time if you're confused. Now that I know that my p-value is less than alpha, what do? I reject my null hypothesis. But what is the verbiage that I use? There is enough evidence at alpha significance level to support my alternative. Remember what we talked about. If I'm rejecting this one, then automatically I am supporting this one. Okay, so let's go ahead and see which one. There is enough evidence to suggest that the average dividend earning per share of the stock is less than 1.6. But what is my alternative? My alternative is more than. So definitely this is not my option. I didn't talk about less than. My alternative is more than, remember? So there is not enough evidence. No, that's wrong because I know there is enough evidence. So even option D is gone because option D says there is not enough evidence. As you can see, almost three options are gone and I'm only left with option C, which says there is enough evidence to suggest that the average dividend earning per share of the stock is greater than 1.6. Why did we say that? Because that was my alternative. Remember? That's why I always ask you all to write your alternative and your null so you can conclude. Remember, when you're using p-values, you either support your alternative or you don't support your alternative. This verbiage is very important, so make sure you write this down and use the same verbiage based on what test you're using, either using the rejection region or the p-value. All right, let's go ahead and do one more problem. A marketing manager would like to test the claim that the percentage increase of company sales after advertising campaign is different than. Keep in mind, what did I talk about? Different is not less, not more. So not equal to. Different than 17%. So I know, did they say average? A marketing would like to test the claim the percentage increase of the company. Okay, so I'm just going to put it as proportion is different, so not equal to 17%. If the z-test, as soon as I write my alternative, what do? I write my null hypothesis. Null hypothesis is simple, always equal to. The test statistic, if the z-test statistic was calculated, what's my test statistic? 2.43, right? That was my test statistic. If that was calculated, does the marketing manager have enough evidence to reject the null hypothesis? What did they say? Assume my alpha is 0.01. You cannot come up with the alpha value, which is your type 1 error, the significance level. The problem should always specify and give you the alpha level. Now, once we have all this, they're asking us to use the p-value. We have to get the p-value. So let's go ahead and look at the p-value. So not this problem. Okay, so here I have it. First step, I'm going to move to what tail test it is. Because, did we write that here? Yeah, because it is not equal to, I know it's a two-tail test. Let me go ahead and do that. Moving once, moving twice, that's right tailed. I'm getting to two-tailed. Okay. And what is my alpha level? 0.01. So 1, 2, 3. That's my 0.01. Okay. And as you can see, as soon as I say it's a two-tailed, alpha is divided by 2 because I'm dividing my alpha into two-tailed because of the two tails on left and right. The next step is your test statistic. My test statistic was 2.43. Da 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 da. Moving, 2.4. Am I getting into rejection region? There you go, 2.43. Now, you can be smart enough and just look at the problem. You see, the test statistic did not fall in the rejection region. So you're not rejecting it. But let's go ahead and use the p-value. What is the p-value? 0.015. The p-value is right here, 0.015. So let's go ahead and type it in. My p-value is 0.015. Okay? All right, now you're going to compare this to alpha. I'm going to change my alpha. Remember what my alpha is, 0.01. So compare it, 0.01. My p-value is greater than alpha. So I'm not rejecting. And when I look back, that's exactly what happened. It did not fall in the rejection region. So I'm not rejecting, right? So it doesn't matter which test you use, they take you to the same conclusion. But because p-value is greater, I am not rejecting. I use my second verbiage or the second terminology. How do I say that? There is not enough evidence. So I'm going to go ahead and cancel off everything that has enough evidence. So this is gone. Scroll up a little bit. And this is also gone. So my option A and C are gone, right? Now what do I say? There is not enough evidence at alpha significance level to support my alternative. So remember, I'm supporting my alternative. What is my alternative? That the percent is not equal to 17% or it's different than 17%. Let's go ahead and take a look. There is not enough evidence to suggest that the average percent increase, was it average? Did it say average somewhere? Okay. The average percent increase of the company sales after advertising is greater than 17. No, my alternative is not greater than. My alternative is different, so not this one either. There is not enough evidence to suggest that the average percentage increase of the company's sales after advertising is not 17%. That's right. It's not 17%. That means it could be less than or it could be greater than. So my option is option D. So you always go ahead and take a look at your alternative hypothesis. My alternative hypothesis says it's not 17. It doesn't talk about less than, it doesn't talk about greater than, okay? And again, please be careful when you are doing these problems. Make sure you have all the verbiage ready for you to take a look and then choose your answers. And again, if you have any questions, please email me or contact me through Teams. Good luck.